On the same day NASA shut down multiple operations, Perseverance's routine system check detected a small distinct mark exactly where 3I/Atlas was predicted to appear. This confirmed the object's presence, but also raised new and unsettling questions. The latest images reveal more than an odd feature. They show something unmistakably foreign, an object from another star system surrounded by a faint carbon dioxide cloud, faint traces that could indicate water, a reflective side facing the sun, unusual light patterns, and most puzzling of all, the presence of nickel without any iron. None of this fits the standard models for comets or asteroids. It's unclear whether this is a rare natural event or if something else is being deliberately obscured, but the evidence demands closer examination. October 3rd, 2025. Although high-resolution images from Mars orbiters remain unavailable, Perseverance's navigation camera quietly captured a sequence that has stirred intense debate. Mission specialists compiled 20 consecutive frames showing a faint, slanted blur moving across the dark Martian sky, precisely at the coordinates where Comet 3I/Atlas should have been. The position matches exactly. Data from JPL's Horizon system confirmed that the object's predicted trajectory passes through the same pixel path in each frame, consistent with a body traveling past Mars at roughly 60 kilometers per second. It cannot be explained by cosmic radiation or debris from any known satellite. The faint blur remains steady and continuous across the sequence, never flickering or vanishing, confirming that something real, and still not fully understood, was caught on camera. It forms a smooth, steady arc that matches the comet's predicted movement across the sky almost exactly. The method used is simple but reliable. Each image, captured seconds apart, is corrected for the rover's position and the camera's angle. When the 20 frames are digitally merged, random noise fades away and consistent patterns become clearer. What remains is a thin, faint line, hard to notice but undeniably real. The timing couldn't be better. The sequence began exactly when Comet 3I/Atlas was closest to Mars, a moment planned well in advance by the mission team. The odds of something unrelated appearing in precisely the right spot at the right time across all 20 images are extremely low. No other Mars instruments have detected anything similar. Specialists at JPL have quietly reviewed the raw data, even though it hasn't been released to the public. They searched for possible errors, camera glitches, radiation interference, or dust effects, but none fit the evidence. The most plausible explanation is that Perseverance, through a mix of timing and precision, captured the comet in real time. The image itself isn't sharp. It lacks the clarity that orbiters like HiRISE or Mars Express could provide. The distant, dim mark offers no visible structure, no tail, and no distinct nucleus. Still, it stands as direct photographic proof that 3I/Atlas was there, moving exactly as predicted along a path nothing else near Mars follows. With no official confirmation yet, the rover's 20 combined frames remain the only available evidence from the Martian surface. It's a temporary but crucial observation, highlighting how limited and mysterious the current data still is. For now, that faint blur from Perseverance is the single most trustworthy clue we have. It confirms that the object truly exists, but it doesn't solve the larger mysteries about its shape, composition, or origin. Until clearer images from orbit become available, this faint streak remains the only piece of evidence separating observation from speculation. Across the solar system, a network of telescopes and spacecraft turned their sensors toward 3I/Atlas, each collecting different fragments of information. The James Webb Space Telescope, observing in infrared, detected that carbon dioxide dominated the comet's thin atmosphere. Its near-infrared data showed nearly 8 times more carbon dioxide than water. An unusually high ratio, since comets within our solar system normally release mostly water vapor. The Swift telescope, scanning in ultraviolet, searched for the typical spectral signs of water and hydroxyl, which are usually easy to detect. But the expected ultraviolet emissions from hydroxyl at 308 nanometers and water at 160 nanometers were faint and difficult to identify. Instead, Swift detected a surprising abundance of carbon monoxide, revealing an odd and unexpected gas composition. Meanwhile, scientists using the Very Large Telescope's 4RS2 instrument measured the comet's light polarization and recorded a value of -2 at a scattering angle of 7 degrees. 3I/Atlas showed 77% polarization, an unusual result since most comets display positive polarization at similar angles. Negative polarization like this is rare and often caused by fine reflective dust grains. Even more unusual, the point where the polarization shifted from negative to positive occurred at just just over 17 degrees, compared to the usual 21. This suggests the dust within the comet's coma has a unique structure and composition, unlike anything previously documented. The Hubble Space Telescope, observing invisible light, captured a wide, uneven halo facing the sun. Rather than a standard tail stretching away from sunlight, the glow scattered toward it, forming an irregular fan-shaped pattern that defies the typical behavior of known comets. The model suggests that closely packed or aligned dust grains could explain the effect, but the overall brightness and structure don't match any known comet. Adding to the mystery, the UV spectrograph from the Very Large Telescope revealed something unexpected: frequent traces of neutral nickel in the gas, yet no sign of iron, which should have been stronger or at least equally present. This is significant because, in all previously studied comets, iron is typically found in quantities at least 10 times greater than nickel. Here, only nickel appeared. Laboratory tests indicate that sunlight should vaporize both elements at nearly the same rate, making this imbalance difficult to justify through ordinary heat or chemical processes. Across 5 major observatories, each instrument recorded something out of the ordinary. Every wavelength, every angle showed the comet behaving differently. A carbon dioxide cloud, faint water emissions, negative polarization, a sun-facing halo, and the absence of iron with only nickel released. No comet observed in recent history has displayed this full combination of features. It's not just a mystery anymore, but a scientific challenge that forces experts to reconsider what defines a comet in the first place. By late August, as telescopes continued their efforts to capture clearer images of 3I/Atlas, a new kind of investigation began circulating through private online communities. Groups dedicated to remote viewing, including one led by Bertie Dworsky, conducted several sessions attempting to visualize an unidentified object in space without prior information. Participants independently described nearly identical images: a small, device-like object about the size of a USB stick encased within a larger mass of ice. Some even claimed to perceive rhythmic pulses or signals, suggesting that whatever was inside might be transmitting something into the void. Some participants described intricate patterns or markings, what a few even called graffiti, etched into a reflective metallic surface buried beneath layers of dust and ice. None of the viewers were told what they were supposed to be observing, and the location, context, and background details were kept secret until the sessions had concluded. These sessions took place before the comet's approach to Mars, at a time when only a handful of astronomers even knew the trajectory of 3I/Atlas. As interest grew, the line between speculation and serious discussion began to blur. The high-rise camera aboard the Mars Reconnaissance Orbiter was prepared to capture a critical image that could confirm or disprove the mounting theories. For a brief period, 3 separate space objects passed very close to Mars, providing an exceptional opportunity for orbiting spacecraft to obtain detailed images far beyond what Earth-based telescopes could achieve. Yet after the flyby, no images were released. NASA, which typically publishes Martian photographs promptly, remained silent. The European Space Agency confirmed that both Mars Express and the Trace Gas Orbiter observed the encounter, but stated that they were still verifying the collected data before releasing anything. Although basic mission updates continued, the high-resolution imagery needed to determine the object's shape and composition never appeared publicly. The delay was made even more conspicuous by timing. During a US government shutdown that left more than 15,000 NASA employees temporarily furloughed, severely limiting the agency's ability to communicate new findings to the public. Essential teams managed to keep the spacecraft operational and ensured the collected data was safely stored, but routine maintenance and the release of detailed images were put on hold. Meanwhile, the European Space Agency faced its own internal complications, further delaying any coordinated updates. To astronomers and space enthusiasts around the world, this silence felt less like caution and more like deliberate obstruction. Rumors began to circulate that the withheld images contained something unexpected, or that the data was being kept confidential for further analysis. As a result, unofficial communities took the lead. Amateur astronomers shared fragments of information wherever they could, while social media filled with speculation, frustration, and theories. What should have been a milestone for astronomy, capturing an interstellar object from multiple perspectives, instead became an example of how bureaucracy can undermine discovery. When people most needed clarity, the system designed to provide it fell silent. Until restrictions are lifted, the story of 3I/Atlas continues through rumors, leaks, and a few indistinct photos from Mars. Taken together, the details surrounding 3I/Atlas seem almost too improbable to believe. There is an object massive enough that its trajectory barely shifts despite venting gas, behavior unlike any comet of similar size. Its luminous haze faces the sun instead of trailing away from it, contradicting the basic physics of how comet tails form. Then there's its composition. Nickel vapor continues to appear without any trace of iron, even though laboratory experiments show both should evaporate together when heated by sunlight. Polarization data, though not fully released, reportedly indicate a sharp shift occurring at a smaller angle than seen in nearly any other comet. This points to dust grains with entirely unfamiliar physical properties, suggesting that 3I/Atlas might not be like anything humanity has encountered before. The object's trajectory is unusual. Instead of darting randomly through the solar system, 3I/Atlas travels along the same plane where the planets orbit. It passes near Venus, Mars, and Jupiter in a way that would be rare even for a carefully planned spacecraft using gravitational assist to adjust its course. Adding to the mystery, its route crosses a small patch of the sky linked to the famous 1977 WOW signal. That signal, one of the most puzzling radio detections ever recorded, had several strange characteristics. Each detail alone might seem ordinary, but taken together, they make coincidence seem nearly impossible. The odds of all 7 peculiar traits appearing in a single object are so small that it's hard not to question what's really happening. It might be a completely new kind of interstellar body, or something even more extraordinary. The story of 3I/Atlas has become a clear example of how nature, or perhaps design, can defy expectations. On October 29th, it will reach its closest point to the sun, about 1.4 times the Earth-Sun distance, marking the moment when theories will be put to the test. If it behaves like a typical interstellar comet, solar heating could cause it to emit gases or even break apart. But if 3I/Atlas is something more unusual, this is when anomalies might appear. Strange motions, flashes of light, or signals that natural processes can't explain. Its path is critical. On October 3rd, it passed just 29 million kilometers from Mars, a relatively close distance between planets, and from there it continues to accelerate, expected to reach a top speed of 68 kilometers per second by the end of October. The most advanced instruments are needed to capture the smallest details. November brings a rare opportunity. The ESA's JUICE spacecraft, designed to study Jupiter's moons, will dedicate observation time from November 2nd to 25th. JUICE's instruments are built to detect faint, fast-moving objects, and the mission team has scheduled specific sessions to track them. If any fragments of 3I/Atlas shift direction or suddenly brighten, JUICE will be prepared to observe it. These observations are crucial since they'll be the last detailed views before the object moves away from the sun and becomes visible again in the morning sky. In early December, astronomers will test the accuracy of its predicted orbit. When 3I/Atlas reappears from behind the sun, its actual position will be compared to the calculated one. Even a slight difference could indicate that it's venting material, breaking apart, or altering course. Davide Finoia and his team at JPL are closely monitoring the data. On December 19th, there will be a final observation when the comet is 1.8 astronomical units from Earth, the last opportunity for Earth-based telescopes to capture detailed images before it drifts into deep space. A fake image of Mitsuaku smiling beside a glowing comet spreads online, accompanied by a fabricated quote about alien probes. In Russia, state media claims Western nations are hiding the truth, while meme pages flood social platforms with jokes about the Perseverance blur using the hashtag #Harbinger. Humor and fear intertwine, amplified by NASA's shutdown and the absence of verified photos. While speculation races across the internet, scientists focus on real data. The Vera Rubin Observatory, active for just over a year, launches a global effort to measure the comet's distance. Amateur and professional telescopes around the world coordinate to pinpoint 3I/Atlas's exact position when it returns to view in December. Scientists are preparing to focus their instruments once more on the 1420 MHz frequency, a range deeply associated with hydrogen, often referred to as the water hole in the search for extraterrestrial intelligence. This frequency is considered a kind of cosmic meeting point where intelligent signals might be most easily detected. Their plan is to direct high-sensitivity receivers toward the region of space where the comet is predicted to appear, hoping to capture even the faintest whisper of a transmission or a natural emission pattern that could shed light on its true nature. Every bit of data gathered at this range could be crucial, as it's the same frequency hydrogen atoms naturally emit, and hydrogen, being the most abundant element in the universe, provides an ideal background for scientific listening. Across the internet, the conversation surrounding these developments has evolved dramatically. Online discussion boards, once filled with wild theories and careless speculation, have shifted toward a more analytical tone. Enthusiasts and amateur astronomers now post precise star charts, link telescope coordinates, and verify each claim against official observatory data. Yet a new tension has emerged: the constant tug of war between unverified viral rumors and methodically confirmed facts. Misinformation spreads with incredible speed, but at the same time, a growing community of fact-checkers works tirelessly to correct it. This strange duality, chaos and order existing side by side, defines the modern era of public science discourse. Meanwhile, on October 6th, Earth came dangerously close to disaster. A small asteroid, designated 2025 TF, barely 2 meters in diameter, zipped past our planet at an altitude of just 419 kilometers above Antarctica, closer than many satellites. What startled astronomers even more was that they detected it only after it had passed. Its orbit remains uncertain, leading to a low confidence classification in the official registry. Such near misses serve as unsettling reminders of how vulnerable our planet remains to sudden cosmic encounters, despite advances in planetary defense technology. Elsewhere in the solar system, Mars continues to offer surprises. In regions like Bright Angel and Sapphire Canyon, researchers have identified patterns that resemble leopard spots from orbit, areas rich in organic material lying adjacent to minerals sensitive to shifts in oxygen. These contrasting zones could represent the most promising biosignatures found on the planet so far. However, the potential breakthrough is overshadowed by political wrangling over the Mars Sample Return Program. Debates about cost, risk, and international cooperation threaten to delay what could be humanity's first opportunity to study Martian life in terrestrial laboratories. Back on Earth, intrigue deepens in Washington. A confidential meeting concerning unidentified aerial phenomena reportedly featured a startling video recorded in Yemen. The footage showed a luminous orb struck by a Hellfire missile, yet the object continued moving as if unaffected. Officials from the Department of Defense have declined to comment, and individuals who have attempted to release related information are reportedly facing serious repercussions. The silence has only fueled speculation, reinforcing public suspicion that much remains undisclosed. Adding to the planet's current turbulence, the sun has been unusually active. Solar winds blasting through space at velocities between 600 and 770 kilometers per second have triggered intense geomagnetic storms. These disturbances have painted the skies with auroras visible far beyond their usual boundaries, glowing vividly over Colorado, Hungary, and other mid-latitude regions. The spectacle, while beautiful, is a reminder of our planet's exposure to cosmic forces far beyond human control. At the same time, the night sky is alive with movement. 3 brilliant green comets, C/2025 A6 Lemon, C/2025 R2SWAN, and C/2025 K18A TLAS, are all visible with the right conditions. Of the trio, Comet Lemon is expected to shine the brightest, possibly reaching magnitude 4, making it visible to the naked eye under dark skies. These comets, streaking silently through the void, add a poetic contrast to the chaos of our own world. Fleeting ancient travelers carrying the story of the solar system's earliest days, even as humanity struggles to understand the mysteries just beyond its reach. Ship 38 is currently undergoing extensive trials to determine how effectively its thermal protection tiles can withstand intense conditions. Meanwhile, across the globe, China's Tianwen-2 spacecraft has begun its ambitious decade-long mission to explore and analyze 2 separate celestial bodies, marking a major milestone in deep space exploration. At the same time, NASA is grappling with significant financial challenges. The agency has been forced to impose large-scale budget cuts that have temporarily sidelined about 15,000 employees, leaving only around 3,000 essential staff members to keep critical systems operating. As a result, several vital space missions may face delays or even cancellation, putting years of research and investment at risk. The current investigation was sparked by an unexpected observation from the Perseverance rover, which captured a set of 20 images revealing a faint distortion at the coordinates where the interstellar object 3I/Atlas was predicted to appear. This subtle visual irregularity prompted a deeper inquiry using 5 of the world's leading observatories. Researchers soon detected a diffuse cloud rich in carbon dioxide and a distinct spectral signature containing nickel, a combination not commonly seen in typical comets. Polarization readings added to the mystery, showing patterns that didn't align with known cometary behaviors. However, detailed imagery from Mars orbiters has not yet been made public, and several crucial chemical findings remain under independent review by multiple scientific teams. Complicating matters further, the so-called anomaly card, a report listing 7 distinct and unusual characteristics of the object, challenges nearly every conventional explanation. Scientists caution that any definitive interpretation must await incoming data from the European Space Agency's JUICE mission, as well as new ground-based observations scheduled in the coming months. In the absence of official updates, speculation has flourished online, but collaborative international teams are now coordinating to verify the object's true distance and to monitor for any potential emissions that could hint at artificial origins. For now, the situation remains uncertain, yet profoundly intriguing. What makes 3I/Atlas especially fascinating is how dramatically it diverges from previous interstellar visitors. Its composition, trajectory, and reflective properties all point towards something we have not encountered before. Yet the full picture depends on imagery and datasets that are still under processing or embargo. Until those materials are released and peer-reviewed, the conversation must rely on partial evidence, a mixture of what has been confirmed, what remains unverified, and what lies entirely in the realm of informed speculation.